June 29th, 1764, seemed like a regular day in one small picturesque town in Germany, Waldeck. Residents were in church. Little did they know that a powerful storm was about to hit the area. It wasn't just an ordinary storm, it was a strong, swirling tornado getting closer and closer. It was an F2 tornado at the beginning, strong enough to uproot trees like oaks and beeches. But as time went by, it grew and became more powerful. It even picked up 2 children on its way and threw them into a lake. Something strange happened too. The water level in the lake rose and then quickly retreated. Leaving the lake behind, the tornado struck a house, tearing off the roof and knocking down the walls. Then the tornado changed direction and headed east-northeast, increasing its intensity to F3 level. That's when something fascinating happened. A possible twin or satellite waterspout merged with the tornado along the shore of Lake Luzin. It was like 2 tornadoes coming together. It got wider and stronger, so it started snapping and uprooting solitary oak trees, flinging them 115 feet into the air. It left behind a barren landscape, removing crops, grass, and even topsoil. Back then, people couldn't even read or write very well, let alone use devices that could predict a tornado. This one was so strong it destroyed houses, barns, and even uprooted trees. Such a terrifying thing to see. But there was something special about the church people were in. It had strong stone walls, so they were safe inside, even though everything outside was getting destroyed. They didn't even realize how lucky they were until later. With winds estimated to be over 300 mph, it was unstoppable. The tornado traveled a distance of 19 miles and stretched to a maximum width of 0.6 miles. A raging storm threw tree branches so high, people believed they ended up in the atmosphere. Another strange thing about this tornado was that it occurred during a dry storm. There was very little rain reported, but the storm still managed to make such a mess. It even produced large hailstones, some as big as 5.9 inches in diameter. Just imagine chunks of ice that large falling from the sky. These hailstones caused significant damage to crops and properties, and everything else that was outside at that time. After the storm passed, one scientist, Gottlob Burchard Gensmer, studied the damage and talked to people who had witnessed the tornado, only to realize this was one of the strongest tornadoes ever recorded in history. It reached F5, the highest rating on what's called the Fujita scale, which measures tornado strength. It took an hour for the madness to stop. Back in 1925, people in northeast Missouri didn't have an organized tornado warning system either. It took them by surprise when one day, in the early afternoon, they saw a tornado forming in that area. At first, it was a small one that briefly lifted off the ground. But as time went by, it started growing into a massive monster. Meanwhile, in West Frankfort, Illinois, some miners were working deep underground, about 500 feet below the surface. Suddenly, the power went out, and they knew something was wrong. They quickly started climbing up the shaft to get to the surface. When they finally made it, they were in for a terrible shock because of the devastating consequences of this giant tornado. The tornado didn't even stop there. It kept on making a mess as it traveled a long distance. It plowed through the land for a whopping 219 miles, all the way from near Redford, Missouri to the east of Princeton, Indiana. It moved at a crazy speed of 73 miles an hour. In one town, Murfreesboro, Illinois, the tornado wiped out a staggering 100 blocks of the town, plus another 70 blocks ended up destroyed by fire. In another town, Griffin, Indiana, not a single building was left standing. The tornado got weaker only at 4:30 in the afternoon. This tornado, known as the Tri-State Tornado, really made history as the worst and longest-lasting tornado ever recorded in the United States. In April 1965, people in the region of the Great Lakes started complaining about this weird heat. The forecast showed no storms for that area. It was because of thunderstorms sweeping across the upper Midwest of the United States. These storms were insane and so powerful they created 51 tornadoes in just 12 hours. The states of Indiana, Ohio, and Michigan ended up being hit particularly hard. Something unfortunate happened during this time. All this caught the forecast team, the National Severe Storms Forecast Center in Kansas City, Missouri, off guard. They quickly tried to send out warnings to let people know what was happening, but many people didn't hear the announcements because there were no outdoor tornado sirens at that time. Additionally, a lot of TV and radio stations didn't regularly broadcast weather alerts. Power was gone, and telephone lines didn't work, which meant many towns were completely cut off from communications. People couldn't receive the warnings because they didn't have access to electricity or working phones. One spring day in 1974 was especially hard because of severe thunderstorms that unleashed a series of powerful tornadoes across 13 states in the United States. These tornadoes lasted for 16 hours, and they ranged from weaker F0 to the most powerful and destructive F5 ones. At one terrifying moment, there were 15 tornadoes touching the ground at the same time. One lasted for more than 2 hours, and 2 others were swirling around each other like dancers. This was another big lesson, after which some changes in tornado warnings were made. In those days, weather forecasters could only warn people about a tornado if they had seen one with their own eyes, which was mostly too late. April 26, 1989, at around 6:30 in the afternoon, the sky above one district, Maniganj in Bangladesh, turned dark and ominous. The tornado began its journey from one point, Daulatpur, and moved swiftly eastward, Saturia, Maniganj Sadar. People living in that region had already been facing a severe drought, and little did they know there were even worse scenarios coming. The storm was fierce, stretching about 10 miles long and 1 mile wide. It covered a relatively small area, but it still caused enormous damage. It tore through the land and blew away buildings, thousands of trees, strong and rooted for years, and everything else in its path. The countryside of Marsala in western Sicily is really beautiful. But it wasn't so stunning on December 8th, 1851. 2 fierce tornadoes suddenly swept across the land, leaving nothing but chaos. As they moved, they brought along heavy rain and hailstorms, causing even more damage to the already vulnerable farmlands. One town, Castellammare, had an amazing harbor with plenty of ships, and it suffered great damage. The news of this devastating event reached far and wide, even making its way to the Illustrated London News. The outbreak in Oklahoma from 24 years ago, May 3rd, 1999, was tough too. Just one stormy day caused enormous damage from Texas all the way up to South Dakota. At least 45 tornadoes touched down, and Oklahoma was hit the hardest with an F5 tornado. The story seemed familiar. What first seemed like a small twister quickly grew into a massive force that, at one point, measured 1 mile in width. This one ripped asphalt from roads, peeling it away in layers like fragile paper. It tore the vegetation away and even wrapped roofing materials around power lines. NASA scientists studied the area using satellites. They realized it would take between 10 to 20 years for the vegetation to fully regrow in the region where the tornado left nothing but muddy, barren land. Oklahoma is in a pretty unfortunate spot when it comes to tornadoes. Take 1947 as an example. The Woodward tornado got named after the city it had struck. This monstrous tornado was massive. It reached 1.8 miles in width, and it raced forward at an incredible speed of around 50 mph. Before reaching Woodward, the tornado had already caused a lot of mess in other towns along its path. But it was in Woodward where it unleashed its worst fury. Without any warning, it struck the city at 8:42 in the evening, catching the residents by surprise. Communication with the outside world was cut off, leaving families uncertain about the fate of their loved ones. As if one tornado isn't enough, some areas get struck by a series of them. In 1908, an outbreak of tornadoes swept across the eastern part of the United States, from Texas to Georgia and then northward from Oklahoma to Tennessee. At least 34 tornadoes touched down. Nature showed no mercy. Buildings were torn apart, and once thriving streets were reduced to rubble. The Fujita scale measures tornado strength based on 2 things: the speed of the winds and the amount of destruction caused. F5 tornadoes are the strongest, most destructive ones. I mean, some people talk about F6 tornado with winds that could blow at over 300 miles per hour. If this one was passing by, you'd definitely know how Dorothy felt. Luckily, F6 exists only in stories, and Oz is the last place you are likely to end up at.
The air is bone dry and the wind is out of control. You feel like you're standing in front of a fireplace, but you're not. You're standing in your backyard about to grill up a feast when you suddenly see the trees shaking uncontrollably. Leaves are falling like confetti. The wind just blew your last piece of laundry into the great unknown. You look around and everyone else is just as confused and scared as you are. In the distance, you see a red horizon of fire in the forest and a large vortex touching the sky. You drop everything and make a break for it. You'll be lucky to outrun a tornado. They usually move at around 30 miles per hour, but can reach up to 70. Imagine running away from a giant twister, hurtling towards you at Usain Bolt speed. The roads are crowded with people trying to find shelter or just get out of town. You get in your car and try to start it, but the wind knocks a sign over. It smashes your windshield. Anyway, a big tornado is powerful enough to swing your entire car around. You gotta go on foot. Best bet? Head for your buddy's house. They have a deep basement stocked with supplies. Whenever a tornado flies on by, try to take cover somewhere underground. If you don't have a basement, avoid any windows and try to stay underneath something sturdy to protect yourself. You're running to your friend's place. Everything around you is getting swept up by the insane winds. But when you turn around, you see the tornado turning reddish. You can barely see it because of the debris, but the spinning vortex, it's on fire. It's a fire tornado. These spinning flame winds can reach 140 miles per hour and can be between 15 to 150 feet tall and as much as 500 feet wide. These monsters occur when tons of smoke get whirled around, so the thunderstorm starts to act like a tornado. By the way, many fire tornadoes can even occur in a bonfire and are called fire whirls. Next time you're camping or setting up your living room fireplace, check it out. You might just spot one spinning around in there. Anyway, it's getting closer and closer, throwing ash all over. It's already pretty hard for you to see where you're going. You use your hands to wave off some of the smoke and ash flying around your face, but it's useless. You keep sprinting as fast as you can until you spot a huge truck. Just park right there in the middle of the road. You crawl underneath. It's one of those trucks that has like 20 wheels. They look so big and heavy up close. Then you hear a creaking sound and a humming sound. The wheels, they look magical. Gracefully, they start lifting off the ground, as if the truck's part of some Vegas magic act. As the tornado gets closer, the wheels rise higher. Better to be far away from here when the truck smashes back down to earth. You crawl out and keep running. You find a convenience store to take cover in, making sure not to stand too close to the glass. You head as far into the store as you can, ready to wait this thing out. But all around you, the land is burning. This fiery twister is a monster, and it's charging towards you. You look out in the distance and see another fire tornado wrecking another part of the city. In order for a tornado to form, it needs open space. That's why many of the tornadoes you see on the news happen in the same part of the U.S., where there aren't many mountains and it's nice and flat. But of course, they can happen anywhere. It's not normal to see tornadoes in the bustling downtowns of America's biggest cities. They need a lot of open space for the rotating vortex to happen. But today is not a normal day. A tornado forms in a supercell thunderstorm. That's when you have two different air temperatures going at it. The vortex you see in tornadoes forms when warm air and moisture come in from above. Below, it's a mess. The end result, the huge spiral funnel cloud we see in every tornado movie. Meteorologists can predict tornadoes somewhat by monitoring the amount of moisture in the air. Every second counts, so keep the TV on next time there's a storm brewing near you. But this doesn't really apply for a fire tornado. The winds are getting stronger and you're feeling the heat even inside the store. Outside, spiraling flamethrowers are torching everything in their path. It may be too late to find an underground shelter. You improvise a way to help protect yourself by hiding underneath the cash register. And now, you can't see anything. There's ash everywhere and the windows are all smashed. Thanks, tornado. Ash is one of the most dangerous parts of a fire tornado, unless you're not really into breathing or seeing. Your best bet would be to stay as low as you can to the ground. Since smoke rises, there might still be just enough oxygen down there. Crawling your way along will prevent you from getting struck by any flying objects or debris. The fires are now spreading, and there's a lot more smoke. The trees outside have caught fire, and there are glowing embers as far as the eye can see. These embers can travel more than a mile and can start fires on their own. Now that it's really going crazy, stuff in the store starts flying about, like the smoke wasn't bad enough. You feel like you're inside a snack-filled erupting volcano. It's only a matter of time before the table you're hiding under will get pulled up into the air. The sound inside the store is intense, like sitting next to a jet engine. You can't tell if you're sweating from the heat or from adrenaline. But suddenly, you see someone at the other end of the store waving at you, trying to tell you something. They have an underground storage room. You're saved. But getting there is going to be a real problem. You see, the table screw's getting loose, getting ready to fly into the air. You find a bottle of water next to you and rip a piece of cloth from your shirt. By using a wet cloth, you're able to filter out some of the nasty stuff in the air to help you keep breathing. So, you crawl your way out from underneath the table and make your way to the underground storage room. But the ground is covered with broken glass, and there are cans and stuff everywhere. Even the cans are starting to heat up. You crawl like a sloth, trying to avoid anything pointy. The fire tornado is still out there, and it's getting even closer. You finally make it, and the clerk pulls you down the stairs. It's dark, but there's a single battery-powered lamp to help you see. When it comes to fire tornadoes, it's best to just wait it out. Most of these firestorms don't last that long. So you relax, or try to, and wash your face in a nearby sink. You wipe off all the black ash from your face and breathe normally again. But as you get a bit more relaxed, you feel the ground shaking. Everything around you starts to fall. You and the clerk duck behind a pile of canned goods. Then the tornado takes it up a notch. The store above you gets lifted up off the ground. The only things left, steel and concrete foundations and a couple of random columns. The steel door that's separating you from the outside is barely holding it together. You can see the screws getting loose. You can actually see fire enter the storage room. Everything in the room gets toppled over in an instant. The wind is even louder than before. But then, it's over. Those few minutes felt like hours. You and the clerk climb out and see, well, not much to be honest. The convenience store looks like it got ripped off like a Band-Aid. And all around you, a town you can't even recognize anymore. The big problem with these fire tornadoes is the fires they leave behind. They can ruin towns, forests, farms, and lives. Check this out! There's a giant tornado heading towards you, and it's so fast. These twisters can move at crazy speeds of more than 250 miles per hour. Plus, they can carve a pathway 50 miles long and a mile wide. Sometimes you can see them coming clearly, while in some cases, low-hanging clouds or rain can hide them, so they sneak up on you and you don't even see them. And in most cases, a tornado can develop so fast that no one can even warn you in time if it's already too close. And now, this insane storm is really close. Maybe you have a couple of minutes to get somewhere safe. Do you have a basement? Go hide. Or maybe, I know this is a crazy idea, but what do you think about going inside a tornado to check what it would be like? Now, some tornadoes appear as rope-like swirls, while others have wide clouds in the shape of a funnel. And here's the second one, right before you. Look at these whirling winds born in a thunderstorm. They extend down from it to the ground. Many times, hail joins the party too. The U.S. itself has something like 1,000 tornadoes per year. Texas holds the record with about 120 tornadoes per year, a record not to be proud of. But you'll generally see most twisters in Tornado Alley, which is a stretch of land in the midwestern part of the U.S. They develop when warm, moist air coming from Mexico meets cool, dry air from Canada. These two clash and turn into a powerful storm that at some point can spawn tornadoes. And you'll see most tornadoes there between April and June, though lately some have come even in December. They can range from a regular dust storm to an incredibly powerful force that can carry away cars, large trees, and even houses. But this is a unique chance. You've never been this close, right? Plus, it's a gigantic one. You don't often get to see such a big one. Okay, ready then? It's getting closer. You feel the wind getting stronger while tossing dirt and debris in your face. You close your eyes and whoosh! You're inside, and it's crazy. Vicious winds are hurling and spinning you around. They're lifting you up at the same time. Feeling dizzy? Feeling like Dorothy from The Wizard of Oz? Now may be a good time to check what's really happening to you, while inside swirling with winds and… oh wait! Is that your neighbor's motorcycle spinning together with you? Hope it'll stay that far away. Now, let's take a moment to catch up. Being in the middle of a raging tornado is actually something you might survive. But I won't lie to you, it won't be easy. The first thing you'd sense would likely be the temperature changes. Inside this crazy twister, it can be 36 degrees colder than outside of it. That's because the center of the tornado funnel spins all the time. All that funneling makes the inside of the vortex way colder, and it makes the air way thinner than you used to. The air would be 20% less dense than, for example, what you would find at high altitudes. Now, I hope you're not planning to stay there for too long. Disclaimer here, the atmospheric pressure inside this swirling vortex is so low that your lungs won't be able to extract enough oxygen. Now, to give you a perspective of all this, breathing inside a tornado is like trying to get some air at an altitude of 26,000 feet. That's a pro level, similar to climbing Everest. So yeah, you'll need some help just to be able to take a regular breath. In short, you'll probably pass out after only a couple of minutes. But don't worry, I brought you this special mask, so breathing is not a problem anymore. Hey, did you notice how smooth the airflow from the inside is? Some storm watchers ended up inside a tornado. Later, they said it all looked so chaotic with all those raging clouds and winds swirling around. But from the inside, the air is surprisingly smooth. But that doesn't mean you'll get a peaceful ride because of it. And it's not a solo party in that thing. The neighbor's motorcycle is not the only thing you'll see there. Wood, bricks, glass, maybe even cars, cows, motorhomes, bricks, roofs, and other big objects. You'd be pretty lucky if nothing crashes into you in all that chaos. With all that debris that's swirling at, for instance, 310 miles per hour, you can hardly avoid it. But let's just say a miracle happens and you got through it. Now you're really dizzy, and you're just wondering when all of this is going to be over and if you're even going to be able to come out of this gigantic tornado. Well, the tornado will eventually slow down. It happens because cool air enters the twister. Just because things are settling down, it doesn't mean you can relax. Well, your stomach can, since all that crazy swirling is done, but the tornado will drop you from whatever height you're on when it stops. If you're somewhere in the countryside, there might be some soft bale of hay to break your fall. Oh wait, we're talking about a twister that's probably more than 45,000 feet tall, so that won't work. I hope you brought your parachute, because now would be a good time to pop it. Nope. Hey, don't worry, I'm all about happy endings, so I'll help you out. Here you go. And now you're slowing down, enjoying the view, if you even see anything around you from all that dizziness. How come there are clear sunlit skies from your left, you may wonder? It's not unusual. Tornadoes often form near the edge of a thunderstorm. It's like a border between two different worlds. And it wasn't even windy. Plus the air was very still before it hit, right? Well, that's common too. Okay, I think you know this kind of scenario is impossible in reality. So it would be best to find a safe spot quickly if a tornado is close by. Use your underground shelter first. And if you don't have one, your basement could be the next best choice. Prepare ahead of time with a battery-operated TV or radio, together with fresh batteries, or a device with internet to be able to hear the latest updates on the tornado. Include some non-perishable food, water, and other essentials prepared too. As it turns out, some people really were picked up by tornadoes, and they managed to go through it. A tornado actually dropped them a few hundred feet away without a scratch. Hey, I'd say that's a whole lot of bother just to save some bucks on Uber. But you can't have a guarantee you'll be safe or where you'll end up. It would be incredibly hard to get out of one of those big and fierce ones, though, like supercells. They fall into the category of the strongest type of storms, mostly thunderstorms. And imagine falling into waterspouts. Those could be fine, though, at least the beginning, because they're weak and they form over warm water. So they could be like a part of your spa day, at least until they move inland and turn into a real tornado. Now, dust devils wouldn't be that pleasant. They're not that big, but we're talking about columns of air that rotate at large speeds. And you can easily see them because of all that dirt and dust they pick up, which is why you need glasses for that. Whoops, wait, I forgot that, so I can't help you this time. But if it makes you feel any better, they're not associated with thunderstorms. Don't know why that would make anyone feel better when I think about it. But if you're willing to jump into a fire tornado, I'll find you a special suit that will keep you safe while spinning through smoke, gas, and flames. I promise. Columns here are narrow and they rise vertically into the air, similar to a dust devil. Of course, the heat is crazy. And as updrafts are becoming stronger, and if there's enough dry fuel, a fire whirl is turning into a real fire tornado that extends from the ground up to the cloud, moving incredibly fast. Okay, let's stop now. I'm pretty dizzy.
What? Tornado?
100 to 115 degrees. Tonight, all of those entrances to Yellowstone National Park will be closed. Disney times all of this out.
Oh no. I need to get to the bunker. Get down from there! What the? Oh no! We gotta hide! Betty, no! Ah! I'm alive? Betty! Ah! Woohoo! Ha 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 ha! What the? Ducks? I can't believe we survived. But how am I going to get back home?
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the U.S. was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a derecho is kind of like a small, average level 1 to 2 tornado. Usually its speed is within the range of 73 to 113 miles per hour. And in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, scientists don't have an exact explanation. But although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.
Now get a load of this. A red whirlwind sweeps along the coast of Australia and heads toward the nearest city. This tornado is unique, not by its color, but by what is hidden inside it. These are great white sharks, hammerhead sharks, tiger sharks, and bull sharks. Shark! They fly inside the hurricane, snapping their jaws and trying to grab a piece of meat. People who look at this bizarre phenomenon from the outside think that they've got something in their drinks. But this is reality. A shark tornado can really exist? Or not? Yeah, let's find out. In 1877, a rather unusual tornado struck a farm in Southern California. About 6 small alligators, about 1 foot in length, fell from the sky that day. In 1894, a tornado traveled through England and dropped poisonous jellyfish on people. There's a version that tadpoles instead of jellyfish fell on the ground that day, but it still sounds quite strange. In Kentucky in 1876, there was a black humor rain. Doesn't sound funny to me. Pieces of meat fell from the sky. The locals tasted them and said it was like mutton or venison. However, later, birds discovered that a flock of buzzards had flown over that area. The birds felt unwell and regurgitated their lunch right in the air. And then, I assume, so did the locals who tried it. In 1947, fish fell from the sky in Marksville, Louisiana. In 2005, there was a rain that contained thousands of frogs in Serbia. In 2010, a small town in Australia was hit by a rain of perches, fish. And now, imagine that all these strange phenomena were caused by one villainous corporation where evil geniuses work, and one of them is you. So, you decide to make the most incredible natural cataclysm in history, a tornado of sharks, or sharknado. It seems like it's impossible, but you're going to try, because you have nothing better to do. So first, we need to understand what a waterspout is. It's a column of rotating air filled with clouds. This vortex occurs during a thunderstorm when warm air releases a large amount of heat. This heat becomes the energy that moves the rising air currents. This warm, moist air goes up, and cold, dry air descends. The difference in temperatures preserves instability and helps tornadoes develop. When it forms over the water, a tornado becomes a waterspout. It can draw in particles of seawater, some objects, and even fish. But everything depends on the strength of this vortex. You've probably seen it when tornadoes lifted cars into the air or tore the roofs off of buildings. There's a video on the internet where a tornado raises cows into the air, and an ordinary cow weighs about 1,400 pounds. Ooh. Now, in comparison, the great white shark is about 4,400 pounds. If a tornado could lift several cows, it could cope with a shark. But besides the great white one, there are tiger sharks, bull sharks, and hammerhead sharks. All of them weigh less. Therefore, there's no doubt that a tornado could possibly lift them into the air too. Okay, now we can assume it's in the realm of possibilities. The next step is to create a real tornado. To do this, you need to heat the air and then make it rotate. The cold air will start to go down and you will get a whirlwind. One engineer from Canada named Lewis built devices that created tornadoes. He made several prototypes before assembling a real vortex engine. According to him, anyone can do it. However, these vortices were small. His device created thin jets of air that swirled and produced mini tornadoes, which then quickly dissipated due to strong winds. Lewis started developing this idea to get a new source of electricity, but he needed to create a giant vortex that would go into the sky to power several houses. He didn't have enough finances and opportunities to do this, but the place where you work has enough money to do it. You take the concept of the vortex engine and invest several $1 million. You build several large turbines that direct air to one point and then heat it with the help of a powerful generator. To give your tornado more destructive power, you electrify the atmosphere. You can control the tornado and change its direction using a special control panel. You little evil mad scientist, you. So you come to the coast of Australia, where there are many sharks of different species. To force them to gather in one place, you must throw several tons of minced meat into the water near the shore. Let me suggest that you don't do this by hand. The sharks immediately come there as soon as they smell the food. But there's a problem. These animals feel changes in the weather and don't approach the center of the storm. Therefore, to make sharks take risks, you need to make them angry and hungry enough. You go, Dr. Doofenshmirtz. You spend millions of dollars to organize large-scale fishing. You throw huge nets into the water, and within a week, catch all the fish, shellfish, and other marine life that can become dinner for sharks. You move all the prey into giant aquariums and wait for the sharks to get hungry. A few days later, you notice many big fish congregating near the shore, looking for food. Then, you buy a couple of tons of ground beef from several butcher shops. You put it in a large container and lift it with the help of a helicopter. You dump the meat in a place where you see a lot of sharks. Lunch attracts fish within a 1-mile radius. At this moment, a large ship with the tornado generator approaches the shore. Hey, can't quit now, right? You start the engines and strong flows of warm air accumulate in the sky. Electricity flashes and condensation creates rain. A powerful vortex begins to form in the sky. You control it and direct it towards the sharks. The whirlwind pulls pieces of ground beef from the water. The dust particles mix with the meat and the tornado turns red. Oh, I think I'm gonna barf. You increase the strength of the wind and see how the sharks begin to rise into the air. More precisely, they jump out of the water to grab the meat and the tornado picks them up. When several sharks are inside the vortex, you direct them toward the shore. People are running in horror. Some sharks fall back into the water and some fall to the beach. The hammerhead shark falls right into the kitchen of a coastal restaurant and eats the whole menu. The shark is also a pig. You direct the sharknado into the city. The storm lifts trees and cars into the air and rips off the roofs of houses. Some sharks fall down to the streets. People are running in different directions. The shark vortex passes through the city, scattering sharks. Of course, sharks don't crawl on the ground and don't try to eat people. They're just in shock and don't understand what's going on. Hey, what can I say? It's a PG sharknado. Even in the ocean, sharks don't like to bite people. All attacks occur because sharks mistake them for seals or other sea creatures, which all look like food. Also, toothy fish can swim up to people out of curiosity. And now they're disoriented and having big breathing problems. Fish need a constant flow of water passing through their oxygen-extracting gills. Depending on the species, sharks can last without water for several minutes to an hour. At this moment, you realize that you have carried out not a villainous plan, but a stupid thing that has caused so many fish to suffer. Now, you need to fix everything. You have several helicopters that can transport the fish back into the ocean, but they're twitching and snapping their jaws in fear. Therefore, to calm them down, you use darts with sedatives. Then you help rescuers to fasten the sharks to the helicopters and lift them into the air. You have to get one fish out of an apartment on the 7th floor. Another shark was lying in the park. A hammerhead caused a big traffic jam on the road, and this tiger shark fell on a fire truck. Fortunately, they all have tough skin and strong muscles that protect them from damage. You pick up all the sharks and move them back to the ocean. No one and nothing has been hurt except for one thing: your reputation. You have failed your villainous plan and need to develop something new. This time, you'll create something that will really terrify people. You will invent a YouTube channel with nothing but ads. Alternate ending. You will invent a mega flood of spiders. Ew.
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the sun heating up and getting denser. As a result, the sun would get way larger than it is now. During this transformation, the sun would swallow Venus, Mercury, and Earth. Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, These eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Winds howled, snow swirled everywhere, and visibility dropped to almost zero. 17 climbers were trapped on top of Mount Everest, running out of oxygen. Did they have a chance to survive? And why would that day go down in history as the 1996 Mount Everest disaster? At the end of March that year, a team of 18 people led to the top by Rob Hall came together in Kathmandu, Nepal. The very next day, they began their 9-day-long hike along the Himalayan paths. By April 9th, they finally reached base camp, which is the starting point for climbing Mount Everest. The journey wasn't easy, and many team members got sick on the way from the altitude. At the same time, another climber, Scott Fisher, was leading his team of 19 people to base camp. When both teams arrived there, they started exercising and learned how to breathe where there wouldn't be much oxygen. On Rob's team, one climber got frostbite on some of his toes, and his throat froze, making it hard for him to talk. On Scott's team, one man had trouble breathing even while at base camp, so he had to use bottled oxygen there. Another severe problem happened with one of Scott's Sherpas. Those guys work as guides and porters for climbers in the Himalayas. They can carry loads up to 2 times as heavy as their own weight up and down the mountain. An average, physically fit adult man can carry a backpack loaded with 1/4 of their body weight without a problem. So those Sherpas are really like real-life X-Men. They've also developed the superpower to survive low-pressure, low-oxygen conditions at high altitudes. Scientists suggest it's because they have lower oxygen concentrations in their blood and more oxygen flows to their muscles. It could also be their genes. In either case, one of Scott's superhuman Sherpas got sick and could barely breathe because of the thin air. He was forced to return to the hospital, but passed away several weeks later. Sadly, it wouldn't be the only demise on that tragic ascent. The teams pressed on and departed base camp on May 6th and reached Camp 2 on the same day. 3 days later, they made their way to Camp 4, the final camp before the summit. The plan was to climb to the summit and return to Camp 4 within 18 hours. Staying too long at such high altitudes, especially without extra oxygen, could be very dangerous. Meanwhile, one climber from another expedition that was also on its way to the top stepped out of his tent without properly attaching the sharp spikes on his boots. Without them, he slipped and fell into a deep crack in the ice on the steep part of the mountain. But after he was rescued, he still decided to climb down the mountain the next day and didn't survive. At that point, the teams were in the zone where there isn't enough oxygen in the air, so it's hard for the human body to survive. Some climbers from the groups met another team who were heading back down the mountain. They told them it was too dangerous to push on because of bad weather, but no one listened to the warning. At midnight on May 10th, climbers from different groups started their journey to the top. Each of them carried 2 extra oxygen tanks, but they knew the oxygen would run out by 5 p.m., so they had to climb up and get back down quickly. The Sherpas who helped set up safety ropes were delayed, so the climbers had to wait for an hour on the steep slopes. Some climbers were less experienced, which slowed the entire group down. The leader of the first group, Rob Hall, had told everyone to turn back by 1 or 2 p.m., whether they made it to the summit or not. Around 1 p.m., the first group of climbers reached the top of Mount Everest. Many climbers didn't turn around at the planned 2 p.m. deadline. Scott Fisher let his team keep going until after 3 p.m. Rob Hall and one of his climbers, Doug Hansen, didn't make it to the top until 4 p.m., far too late to start heading back safely. By then, the weather was getting worse. By 3:30 p.m., a storm began rolling in, and by 6 p.m., it had become a full blizzard. Some climbers got back to camp safely, but by 10 p.m., half of the group was still stuck in the storm. One group was stranded at 27,000 feet, just 200 feet from Camp 4. The blizzard made it impossible to see, so they decided to huddle together and wait for the storm to pass. Rob Hall and Doug Hansen were stuck near a steep, icy section called Hillary Step. Hansen collapsed, and Hall stayed with him. Hansen's body was never found. Later, Sherpas found the bodies of other climbers at different altitudes on the mountain. The disaster took 8 lives in total and injured others. It was the highest number of fatalities within 24 hours on Mount Everest. 5 years after that, the mighty Everest did everything to stop Marco Sevridi from being the first person to snowboard all the way down its summit. The route he chose for the descent didn't have enough snow, so the French mountaineer and snowboarder had to choose another one. After just 660 feet of the journey, a fastening strap on his snowboard broke because of the cold. A Sherpa helped him to repair it, and he finished the descent to 21,000 feet in 2 hours. The next year, Marco came back to repeat his success on a different slope of Everest. It was August, so it was kinda late in the season, but it didn't stop him. Marco reached the summit with 3 Sherpas on the 8th of September. He was really tired by then, and the weather was changing, so his guides told him not to go. But he didn't listen. The Sherpas lost sight of him several times. About 4,300 feet below Camp 3, the Sherpas saw a distant figure of a man who stood up and then disappeared down the mountain. No one ever found either Safridi or snowboard tracks leading to his last refuge. But we might still hear about Marco, as it sometimes takes about 100 years to find traces of someone who was lost on Everest. On June 8, 1924, Andrew Sandy Irvine and George Mallory set out to do something no one had ever done before: reach the top of Mount Everest. But something went wrong, and the two men vanished in the icy heights. No one knew if they had made it to the summit before disappearing. If they had succeeded, they would have beaten the first ascent record that was set only 29 years later. In 1999, climbers found Mallory's body on the mountain. But then, for some reason, the body mysteriously disappeared. Climbers couldn't locate it with drones or cameras, even though they had the exact coordinates of the spot. It looks like someone moved it, but no one knows why. Then one day in September 2024, a team working on a National Geographic documentary spotted something unusual: a boot sticking out of the ice on a glacier far below the steep north face of Everest. The leather looked old and cracked, and the steel hobnails on the sole were from a time long ago. Inside the boot, they found a sock with a red label stitched inside. It said A.C. Irvine, confirming that these were Sandy Irvine's remains. A few days earlier, while hiking down the central Rongbuk Glacier, the team had discovered an old oxygen bottle from 1933. That bottle wasn't connected to Mallory and Irvine's climb, but it helped the team figure out where objects and bodies might fall if someone slipped down the mountain. Irvine had carried a small Kodak camera during the climb, and many believe the photos inside it might hold the answer to the biggest question: had they reached the summit before they passed away? Members of Irvine's family have offered DNA samples to confirm his identity. It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So, the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together.
Marriage is not only about happiness, mutual support, love, and friendship. Marriage is also about trials, crises, and storms. And this Swedish couple survived several storms during their honeymoon. Literally. Not screams, insults, and drama, but real hurricanes, fires, earthquakes, and other natural disasters. This is a really cinematic love story. Newlyweds against nature. Meet Erica and Stefan. They met in Stockholm while working on a joint project, parted, but started chatting with each other on social networks. Their long-distance communication lasted for several years before Stefan decided to ask the woman out on a date. And it's worth paying tribute. It wasn't a typical date in a restaurant or in a park. Stefan suggested that Erica fly with him to go diving in Egypt. They realized that they both loved to travel and finally fell in love with each other. After a fabulous wedding and the birth of a beautiful daughter, the couple decided to go on a 4-month honeymoon. The tour was impressive. From Sweden to Indonesia, then to Australia, New Zealand, Japan, and China. They didn't expect that the trip would turn out to be a real adventure where safety was not guaranteed. At first, they got stuck at Munich airport. All flights were delayed because of a severe thunderstorm. In Bali, Indonesia, they went to a high mountain with their little daughter. A strong wind began to blow at the top. It tore off the roof of the tourist bus where our heroes were sitting. Fortunately, no one was injured, and there were no other problems. But at that moment, it was just a teaser of the coming disasters. The couple arrived in Australia, where a wildfire first started near the city of Perth. Stefan and Erica didn't want to cough up thick smoke, so they quickly left for the city of Cairns. It was during that period when a ferocious cyclone began there. The storm was so strong that the Australian Red Cross Service provided shelter for 2,500 people in the mall. And there, another problem began. Imagine 2,500 people in a big, hot room without electricity while a hurricane is raging around. Oh, and there were only 5 toilets in the entire building. How nervous do you think people were? Eric and Stefan recall that some guys started fighting because of stress. The tension was getting stronger, but fortunately, the mall guards kept the situation under control. Wildfires, hurricanes, it seems that something is missing. Oh yes, what about an earthquake? The couple faced 2 earthquakes during their honeymoon, one of which happened in Japan in 2011. They went through all this together with their little daughter. Just imagine how their daughter was amazed by all these adventures. Such a trip strengthened their marriage. Of course, after natural disasters, any domestic quarrel would seem like a mere trifle. Erica admitted that in crisis situations, Stefan fully justified her trust and behaved as she had hoped. Oh, how sweet. What if we create tours for married couples who are planning to divorce? Survive the storm, fire, earthquake, and flood together, and then think again whether you should leave each other. Imagine that you've gone through several natural disasters in your entire life. Now the question is, are you lucky because you've survived, or are you an unlucky person because you've run into such troubles? It depends on how you feel about it. For example, there's a woman, Dana Weiland, who lives in California. She has survived several disasters throughout her life and continues to smile. And more recently, she's faced another disaster, wildfires in her home state. But let's take it in order. In 2005, Dana Weiland lived in New Orleans, and if anyone doesn't know, that year, Hurricane Katrina destroyed many houses in this and other cities. Dana's house was no exception. According to her, the lower floor of the house was completely flooded with water. Of course, she had to give up everything and evacuate. Dana and her family drove to Texas to a friend's place for about 20 hours. 1 month later, Hurricane Rita arrived there, and Dana and her family evacuated again. It looked as if nature was following her around, but our heroine was not one of the timid ones. Several years later, she faced another disaster, Snowmageddon. This was when a huge amount of wet, cold snow flooded cities and roads. Strong wind, blizzard, and endless snowfall. All traffic stopped. The lights turned off. The streets were empty. Dana sat for 11 days without electricity during this snow apocalypse. And after all these disasters, she got the exact opposite of snow. Wildfires in her hometown of Lake Arrowhead in San Bernardino County. Let's hope that this time, everything will be fine with her again, and she will meet any adversity with a smile on her face. Have you heard that lightning doesn't strike twice in the same place? Can it hit the same person twice? What if it strikes the same guy 7 times in a few hours? This is not a movie plot in a tragicomedy genre. This is the real story of Roy Sullivan, a man who got into the Guinness Book of Records for the number of lightning strikes survived. There are more than 8 million lightning strikes on Earth every day, which is about 100 strikes per second. But even so, the probability of getting struck is extremely low, 1 chance in 10 million. For Roy Sullivan, these chances were too high. For his strange record, people nicknamed him the Human Lightning Rod. For the first time, lightning struck him in 1942, when Roy was on a watchtower that didn't have a lightning rod. A bright flash of light and a powerful current discharge scarred the man, but didn't cause crucial damage to health. The next accident occurred in 1969, when lightning struck a tree near the road. The lightning passed through the tree to a car. Guess who was driving this vehicle? Roy lost control and almost drove off a cliff. Fortunately, he stayed alive again. Okay, the first time he was on the tower during a thunderstorm. The second time was on the road next to a tree, and as we know, lightning often strikes trees. This meant Roy was in a potential risk area every time. But the third time happened in his front yard. Lightning struck the transformer and caught his shoulder. The fourth time happened in 1972. Lightning struck Roy while he was working. From that moment on, the man began to suspect that this natural phenomenon was somehow attracted to his body. Maybe it was a curse, or maybe everything could be explained from a scientific point of view. A year later, lightning struck him for the 5th time. A thunderstorm started that day. Roy decided not to try his luck again and hid in his truck. And so, when the storm calmed down, Sullivan got out of the car and bam! Another lightning strike. There were 2 times left before the record. They occurred in 1976 and in 1977. Roy's bad luck spread to his wife. One day, lightning struck her too. It didn't hurt her, but scared a lot. So far, no one has broken Ray's record, but obviously people haven't tried to do that. Okay, lightning, fires, snowstorms, hurricanes, and earthquakes. But how about tsunamis? Unfortunately, this is one of the most terrible and devastating disasters on the planet. If you survived it, you're definitely lucky. Zarul Fuadi from Indonesia survived these devastating water disasters twice. The first occurred in Indonesia in 2004. And the second happened a few years later during an earthquake in Japan. During the second time, Zarul was in the building on the 3rd floor and felt a jolt. He was shocked and immediately remembered the tsunami he had experienced before. The tsunami hit the city, but our hero and his family survived. After this double trouble, he decided to move to his homeland, Indonesia. Despite the terrible events, Zarul looks at what happened calmly. Any catastrophe can happen to any person at any moment, but it doesn't mean you should live in fear forever. So, he focused on the bright side of life. The snowpack over your head splits in 2 right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
So if you see a rainbow, that means you're in for some good luck. But if you see a deep-sea fish, this means that something tragic is about to happen. Let's have a look at ancient lores and what they might mean IRL. In August 2020, people started out their day just like any other in California. It was sunny, so they decided to soak in the sun at the beach. They were snorkeling and kayaking when one of them spotted something out of the ordinary – a doomsday fish. The creature was 12 feet long. It's known as an oarfish, and only about 20 of them have washed up in California since 1901. Oarfishes live in obscure parts of the ocean, but why are they linked to doomsday? Japanese folklore says they are harbingers of disaster. These creatures were once thought to be sea serpents, and they are known as the messenger of the beautiful palace at the bottom of the ocean. The thing is, they only left the beautiful palace to warn humans about a disaster. That's why they're mainly known as bad omens. And when you see one, you can expect to see a tsunami or an earthquake right after. Even oceanographers confirm that this is a famous association. Now, here's where it gets weird. The oarfish washed up near San Diego shores on the 10th of August. And then, on the 12th of August, a magnitude 4.4 earthquake hit Los Angeles. That's not the first time it happened. In 2011, in Japan, about 20 oarfishes were found stranded on the beaches and coastlines of Tehuco. Right after that, a magnitude 9 earthquake and tsunami hit the city. Something similar happened in the Philippines. On February 8, 2017, an oarfish was seen. 2 days later, a magnitude 6.7 earthquake struck the city and its nearby provinces. Sure, there is no way to prove both events are connected. The Seismological Society of America is adamant in saying that this is pure superstition. A recent study analyzed the coincidences and concluded that this association is statistically untrue. Can we say this happened literally out of the blue? Humans have historically noticed animals acting strange right before natural disasters. Earthquakes, floods, even tsunamis. It's like animals can sense something we can't. In fact, there's a lot of science to back it up. Studies show that animals can detect subtle environmental changes, like shifts in the Earth's electromagnetic field or infrasonic sounds, things humans wouldn't notice. This happens because most animals have a wider hearing range than humans and have extra sensitive senses that help them detect gases emitted from the Earth. This theory got famous after the tragic tsunami that destroyed several cities and villages in Indonesia back in 2004. Most man-made warning systems shut down and didn't serve their role of warning humans about the disaster. Sensors were out of action due to maintenance, while other coastal areas simply didn't have any tsunami warning systems. Terrible timing, I know. Still, minutes and hours before the 30-foot wave hit the city, some animals sensed the danger and fled. Eyewitnesses say that elephants ran for higher ground, while flamingos abandoned their low nesting areas and dogs refused to go outdoors. A local reported that he saw a herd of buffalo turning their ears toward the sea and then stampeded to the top of a hill. A lot of the people that survived the tsunami used animals as their warning systems. Now, this is not the first time humans have relied on animals to save their lives. The first official account of when it happened dates back to 373 BCE. I wasn't around then, but the Greek historian Euclides reports how the local population saw rats, weasels, and snakes running from the town before a massive earthquake hit. So what exactly is it that animals can sense that humans can't? To find that out, scientists put biologging tags on cows, sheep, and dogs living in Italy. For about half a year, they tracked the animals. During this time, official statistics recorded over 18,000 quakes in the region. The most shocking information was that animals began to change their behaviors up to 20 hours before an earthquake. Before an earthquake, something called positive holes happen. It's an electric charge that flows from the crust up to the surface of the Earth. They can change the air molecules above where they appear, and animals can pick up on them. There's also evidence that animals might sense changes in groundwater. Before earthquakes, the stress in fault lines can release radon gas, which could alter the chemistry of groundwater. Animals that rely on it might detect these changes and react. Birds are also super sensitive to shifts in the Earth's magnetic field, which can change just before a quake. Another research happened near Mount Etna. Located in Sicily, Italy, it's one of the most active volcanoes on the planet. In 2002, a massive eruption wiped out a ski lift, 2 hotels, and a series of shops located near Etna. So, over the past years, a group of researchers decided to track goats living next to Etna. Their big aha moment came in 2012, when the goats started to act erratically 6 hours before Etna started to spew lava. These researchers were able to retrospectively predict around 7 disasters over the course of 2 years, all thanks to these goats. Back in 2014, a group of scientists studying golden-winged warblers in Tennessee noticed something odd. The birds had taken a detour from their customary breeding grounds. These little birds flew 435 miles from the Cumberland Mountains, where they had just arrived after flying over 3,000 miles from South America. Right after the birds left, a series of more than 80 tornadoes struck the area, causing over $1 billion in damage. What these birds did is something scientists call an evacuation migration. They sensed the tornadoes coming from over 250 miles away. Infrasound is a big disaster giveaway. Storms and tornadoes make very strong infrasounds that can travel thousands of miles from the storm. Now, infrasounds are low-range frequencies, anything ranging below 20 Hz. With our normal set of human ears, we would never hear this. We have an average hearing that ranges from 20 Hz to 20,000 Hz. That means you can hear something like a very, very low bass note or as loud as the buzzing of a mosquito right next to your ear. An elephant's hearing range can reach below 20 Hz. This would make elephants expert at detecting disasters. Scientists also think that detecting infrasound is what helps birds dodge storms when they must cross the ocean. You see, the Pacific Ocean is known to not be at all passive. Although courageous humans venture to cross it, they're usually met with severe storms and conditions that their satellite instruments sometimes can't detect. Meanwhile, there's an ongoing project from France's National Museum of Natural History that is tracking more than 100 birds on their annual crossing over the Pacific. With the help of the International Space Station, they're trying to understand how these little creatures respond to natural hazards en route. But not everyone's convinced. Some scientists argue that while animals might be sensitive to environmental shifts, predicting disasters based on their behavior is too risky. The U.S. Geological Survey has pointed out that many reported cases of unusual animal behavior before disasters are anecdotal, meaning stories and reports, and large-scale studies have yet to prove a direct link. Although humans don't have these super capabilities of predicting disasters, we have some things that might help us. Notice this. The next time you're in a place where lightning is going to hit, your hair will give a sign. If it stands on end, this means that lightning is aimed toward your beautiful person and is about to hit you. So run, find shelter, get inside a house. That's the best you can do in a situation like this. It only takes a moment for a routine flight to turn into a gripping survival story. In a world where a wrong button or an unexpected gust of wind can lead to a disaster, adhering to safety rules is crucial for everyone. From buckling seatbelts to raising window shades during landing. We got all these rules learning from our mistakes. Stay tuned to find out more. A flight had a crazy mid-air moment in 1993 when the pilot accidentally deployed the wing slats, the part on the leading edge of the wing. Now, the weather was fine, passengers were relaxed, everyone was doing what they wanted. Suddenly, they felt an unexpected jolt. Instantly, the autopilot disengaged. The captain started wrestling with the controls. The plane became wonky, pitching and rolling dramatically, resulting in a rapid descent of 5,000 feet. The vibration threw the cabin into total chaos, with passengers screaming in fear. The slats were only to be used during takeoffs and landings, not in midair. It was China Eastern Airlines Flight 583, cruising over the Pacific on its way from Shanghai to Los Angeles. The pilot declared an emergency and directed the plane to an Air Force base in Alaska. Out of the 255 people on board, 60 ended up in a hospital, and sadly, 2 didn't make it. The pilot made some quick moves to stabilize the aircraft, but the injuries happened because folks weren't buckled in. They reckoned that the slats deployed because of the design of the control handle. The company was to blame for that. They produced it in such a way that the handle could accidentally get jiggled while cruising. Luckily, the crew was trained, and the airliner itself was fine, except for the messed-up cabin. The aftermath of this incident was costly, requiring about $1.5 million to repair the damage. When the plane started to lose altitude, overhead lockers burst open, and the safety video played 3 times for an eerie touch. Once the aircraft steadied, Flight attendants jumped into action, providing first aid, leaving empty kits scattered in the cabin. It turned out that the poorly designed slat control handle had caused 11 similar incidents before. The captain probably nudged it accidentally while fixing the speed controls. The lack of pilot training on high-altitude issues and the stall warning system made things worse. If the passengers had kept their seatbelts on, injuries would have been way less severe. This has been the case during many other accidents. You probably know this airplane announcement. Even when the seatbelt sign is off, buckle up when you're seated. Experts say it's a good call. While flying is safe, keeping that seatbelt on is smart because you might hit unexpected turbulence. It's about keeping you secure during that bumpy, jarring time, especially that sneaky one during stormy weather. Sarah Wilson, the president of the Association of Flight Attendants, thinks the seatbelt sign should be turned on throughout the entire journey. Predicting turbulence is like trying to guess the weather. It's not 100% accurate. Turbulence can happen anywhere. Aircraft are tough. They can handle really bad turbulence. The real risk is getting injured during turbulence, not planes falling apart. It's rare, but accidents still happen. In a dramatic episode in 2016, a pilot pulled off a superhero move, saving 439 lives. He was getting ready for takeoff in Shanghai. All of a sudden, another plane showed up on the runway in front of him. Reacting with lightning-fast speed, the pilot swiftly elevated his plane, narrowly avoiding a disaster. The pilot was awarded $360,000 for his remarkable skills. He missed the other plane by less than 67 feet, about the length of a semi-trailer truck. It turned out that the air traffic controllers and the landing crew had mixed things up. 2 controllers lost their licenses, and 13 others got in trouble. They say this incident was like a throwback to the Tenerife airport collision in 1977. Back then, 2 jumbo aircraft collided on a foggy runway. They didn't get lucky that time. The incident was a total disaster. Certain accidents in aviation history prevented others. With each crash, something crucial is upgraded. In 1956, 2 planes collided over the Grand Canyon, resulting in the tragic loss of 128 lives on board. This accident kick-started a $250 million air traffic control system enhancement. The Federal Aviation Agency also appeared in 1958 to keep an eye on air safety. Then in 1986, a private plane accidentally entered the Los Angeles control area, colliding with another aircraft. This tragedy took 86 people's lives. In response, collision avoidance systems were introduced. In 1978, United Flight 173 faced a landing gear problem. This led to a crash that claimed 10 lives. This incident triggered a transformation in cockpit training, introducing cockpit resource management. This management method shifted away from the traditional captain-centric approach to emphasizing teamwork and communication among the crew. Another upgrade was about averting in-flight emergencies. In 1983, Air Canada Flight 797 had smoke in the rear lavatory, which led to an accident that took 23 lives. The FAA responded by requiring smoke detectors and automatic fire extinguishers in aircraft lavatories. Post-1998, planes got retrofitted with fire-blocking seat cushions and floor lighting, with newer ones adopting flame-resistant materials. Winds can be dangerous in certain circumstances. The crash of Delta Flight 191 in 1985 brought attention to the dangers of wind shear. Research efforts by NASA and the FAA led to the development of forward-looking radar wind shear detectors. By the mid-90s, these became standard on airliners. The number of wind shear-related accidents has reduced significantly since then. In 1985, United Airlines Flight 232 faced a nightmare when the DC-10's engine failure left it virtually uncontrollable. Pilot Alfred Haynes landed the plane at a nearby airport, but the subsequent fire was terrifying. 185 passengers survived the catastrophe. The root cause of the incident was a crack in the fan disc, which occurred during the manufacturing of the titanium alloy. This incident prompted the FAA to modify the hydraulic system, implement redundant safety systems in future aircraft, and revolutionize engine inspection protocols. In 1988, A big chunk of an Aloha flight's fuselage ripped off in mid-flight. In an instant, the cabin was torn open, leaving the passengers exposed to the open sky. Despite the chaos, the pilots managed a safe landing, with only one fatality. The NTSB found that corrosion and fatigue damage, which had accumulated over 89,000 flight cycles, had caused this accident. The plane had been used for short-hop pressurized flights between the Hawaiian Islands. Shortly after, the agency initiated the National Aging Aircraft Research Program in 1991. This program tightened inspection and maintenance standards, especially for high-use and high-cycle planes. About 80% of mishaps happen in the first 3 minutes after takeoff or the last 8 minutes before landing. Keep your eyes peeled during these times, and your survival chances will go up. Now, don't let that freak you out. The odds of actually getting into a plane crash are like 1 in 11 million. That's the same possibility as being struck by lightning in a given year in the United States. Planes, on the other hand, often get struck by lightning, but they're built to handle it. Each plane probably gets zapped about once every year or every 3,000 hours it's up in the sky. But there hasn't been a lightning-related accident since 1967. Engineers have ensured that when a plane gets hit, the lightning just zips right through it and out, without really messing up anything inside. Let's delve into the fascinating mechanics of how planes stay airborne. The wings are important, but it's not just about them. There are 4 forces at play: lift, thrust, drag, and weight. The little tails on the ends of wings are called winglets, and they help reduce air swirls, making the aircraft slicker and faster. There's a reason why lights dim when a plane lands at night. It prepares everyone for a quick evacuation, helping the eyes adjust to the dark should the landing go awry. You're in a bright room filled with obstacles, and suddenly the lights go out and you're asked to dash for the exit. Tricky. Flight attendants also ask you to raise those window shades during landing. In case of an emergency, they want you to be able to see what's outside and figure out if one side of the plane is better for a quick escape. If you're wondering where the safest spot in an airliner is, it's in the back. According to research conducted by Popular Mechanics, spanning from 1971 to 2005, sitting in the back gives you a 40% better shot at making it through an accident. Almost as importantly, you're closer to the restrooms.
Bet you never heard this story about the Titanic. So, this massive luxury ocean liner was heading out of Southampton on its first voyage to New York with over 2,000 passengers and crew on board. I'll spare you the details for now. You know how it all went down. Since there were a lot of things that went wrong during its short lifespan, some couldn't help but wonder, was it really bad luck? Or was there some mysterious force behind the ruckus? Well, for starters, right as it was leaving the harbor, the Titanic nearly crashed into another ship, called the SS New York. How did that happen? Well, 6 tugboats had to pull the massive Titanic into the river to begin its journey. Captain Smith was in charge, but let's be honest, he probably needed a few more cups of coffee before making any big decisions. So, as the Titanic was speeding along, minding her own business, she passed the New York and the Oceanic ships. The Titanic decided to make a left turn, but the suction was just too much for the poor New York. She started to drift off towards the Titanic. The Oceanic was leaning so much, her gangplank smacked into the water like a belly flop in the pool. Thankfully, the captain of one of the tugboats was there to save the day. He used his trusty megaphone to call the Vulcan to the port side of the Titanic to pick up some crew members. He then noticed the New York in trouble and acted quickly, throwing a line to slow her down. The Titanic's captain was probably scratching his head, wondering how to handle these big ships like the Titanic. That's because he'd only recently experienced sailing on larger ships. Close one, right? Well, it was just part of the story. As it turns out, the huge list of misfortunes might have started even earlier. Another theory suggests that during the ship's construction days in Northern Ireland, a fire broke out in the coal bunkers. Talk about a rocky start. If this information is correct, then the ship's hull may have been affected by the incident before it even set sail. Fans of this theory argue that a fire popped up inside one of the Titanic's large coal bunkers and really damaged an important segment of the ship's hull. Some claim there's even photographic evidence to back this up. A bunch of photos documenting how the ship was made and pampered for its maiden voyage were found, and they showed a significant black streak on the outside of the Titanic's hull. Weirdly enough, the streak was really close to where the iceberg hit during that cold April. Now I know what you're thinking. This theory might sound far-fetched, but most of these people have been gathering information about the Titanic for decades, and they're convinced that this is the real deal. They even believe that the fire started way earlier than the day the Titanic set out on its maiden voyage, particularly about 3 weeks prior. Why was this overlooked? Well, because of fear of bad press, mostly. Also, because of all the fuss created around the unsinkable ship, it was important that they stuck to the initial calendar. Of course, not everyone is convinced by this new theory. Some people think it's just another wacky idea to add to the long list of Titanic sensational theories. What if I told you there were even rumors about part of an ancient Egyptian coffin being on board? Could that have had something to do with the disastrous ending of the Titanic? Some truly believe it did. Let me tell you the story about the unlucky mummy. It's a tale that'll give you goosebumps. Back in the 19th century, this ancient Egyptian artifact, a mummy case lid to be exact, was brought over to Europe. And as soon as it arrived, strange things started happening. Now, some of the stories may be a bit exaggerated, but according to journalists, some of them were actually true. The rumors sparked the interest of a British writer who later spent months investigating the mummy case and its alleged related stories. He was planning to write an article debunking the myths, but he found out they were all too real. Unfortunately, he never got to finish his work because he passed away suddenly. Others believed that the mummy case was guarded by Egyptian elementals. They warned others not to mess with the artifact. The mummy case's history is just as spooky. It was found in Egypt and sold to a certain someone conveniently named Mr. W at a party organized by a well-known English lady. When the mummy case arrived in England, it was given to Mr. W's sister, who immediately suffered from financial losses and other troubles. A photographer who took a picture of the case claimed that he captured a living woman's face on the film. The mummy case eventually ended up in the British Museum, and it's still there today. However, rumors say that it was aboard the Titanic and was responsible for its sinking. But don't believe everything you hear. Some sources claim the mummy case never left the British Museum, and the rumor was started by a journalist named William Stead. He was actually a passenger on the Titanic, and he supposedly told his fellow passengers about the ill-fated mummy before the ship went down. Is that what happens when you tempt fate? Seriously doubt it, but it does make you wonder, doesn't it? It gets even weirder, trust me. About 50 passengers got cold feet before the ship took off, and they refused to board the Titanic at the last minute, even if it meant that they'd lose the cost of the ticket. They just had an extremely bad feeling about the whole deal. And even an Irish astrologer warned against making the voyage on the Titanic. I doubt he saw a big ol' iceberg hidden somewhere in the stars, but it does add up to the mystique surrounding the Titanic. And do you know what's even worse? The fact that the ship's binoculars, which could have helped prevent the iceberg collision, were locked up. Apparently, those binoculars could have been used by lookouts on that fateful night. But guess what? The key was held by David Blair, an officer who was sadly bumped from the crew before the ship's departure. Poor guy. He probably didn't even know what he was holding on to. Now, some historians think that if those binoculars were in use, the iceberg might have been spotted earlier. But hey, let's not point fingers here. Others argue that it wouldn't have made a difference. Who knows? Maybe the lookout was too busy looking at the stars to notice a giant iceberg in front of them. But seriously, what were they thinking? Locking up the binoculars on a ship that big is like forgetting to pack sunscreen for a trip to the beach. Also, the ship might have been going a bit too fast. Now, I know what you're thinking. Why was the captain in such a hurry? Well, apparently, good old Captain Smith was trying to beat his ship's older sibling, the Olympic, in a race to see which ship could cross the Atlantic faster. I guess he had a bit of a sibling rivalry going on or something. But here's the thing. Even though there were warnings about icebergs in the area, the Titanic just kept on chugging along at full speed ahead. I mean, come on, guys, it's not rocket science. If you know there are icebergs around, maybe slow down a little bit, right? And then, close to midnight on April 14th, 1912, the Titanic hit that iceberg and sank in the North Atlantic. It also famously had a mere 16 lifeboats and 4 collapsible dinghies on board. No wonder it ended up being one of the worst maritime disasters in modern history. After the whole event, people started believing in life beyond the veil and contacted mediums, hoping for signs from the ones they had lost at sea. Can't say I blame them, though there's no verified story of someone managing to contact a Titanic passenger from the beyond, though. Seen a good horror movie lately? If you're a fan of those, then you can appreciate a good plot. But what if I told you that Mother Nature is the best scriptwriter ever? Ancient disasters were scarier than any horror movie today. From tsunamis to volcanic eruptions, you'll be shocked by the scale of these events. One natural disaster you definitely don't want to experience is a tsunami. Those gigantic walls of water sweep across the coast and take out everything in their way. And it's nothing new for our planet. Scientists were able to piece together a timeline based on evidence that major tsunamis left. In northern Chile, a large boulder sits high above the Pacific Ocean. Behind it, a desert as far as the eye can see. This 44-ton stone obviously doesn't belong here. It's the result of an ancient tsunami. Waves as high as a 6-story building carried boulders like pebbles. Researchers estimate this happened in 1420. But how can they possibly know this? In the 15th century, there were no written records in the region. Time for some detective work. Archaeologists discovered that around the same time, there was a tsunami in Japan, on the other side of the Pacific Ocean. The ground shook off the coast of Chile. That's how the tsunami was created. Then the wave traveled nearly 2/5 of the Earth's circumference. That's one tireless tsunami. But this wasn't a one-time event. Evidence suggests that a similar event happened 3,800 years ago. Ancient people abandoned their coastal villages around this time. They were moving inland. How did they know it was time to go? There's evidence of erosion due to strong currents, telltale signs of an ancient tsunami. As you know from school textbooks, oxygen is 21% of the air we breathe. But it wasn't always a part of Earth's atmosphere. Oxygen was missing during the first half of our planet's lifespan. Carbon dioxide and methane were the name of the game back then. CO2 is what makes our drinks fizz. But isn't the other gas dangerous? Yes, because you can't smell methane. And that's the reason there was no life on Earth billions of years ago. So how did we get from methane to oxygen? In come the cyanobacteria. This group of microbes started to evolve some 2.7 billion years ago. These tiny microbes mastered photosynthesis, converting sunlight into energy. And the byproduct of this process was, you've guessed it, oxygen. Soon it started escaping from water into the atmosphere. There, it reacted with methane, and over time, O2 replaced it completely. Scientists named this process the Great Oxidation Event. But how could it be bad? After all, we're alive thanks to it. All that oxygen acted as a poison for anaerobic organisms. And no, these are not life forms that didn't do aerobics or Pilates. The term simply means that these microorganisms didn't need oxygen to grow. Too much oxygen, and they would be goners. And that's precisely what happened. Scientists spoke of an oxygen overshoot that changed Earth's atmosphere for good. The disappearance of most anaerobic organisms was an early example of an extinction event. They didn't like the atmosphere at the time and decided to step down. But look on the bright side. They made room for oxygen-loving humans to enter the picture. Let's go to Turkey. No, not the seaside resorts that tourists visit in the summer, but the region of Anatolia in the southeast of the country. Göbekli Tepe is the world's oldest known temple site. It dates back to the Neolithic period. Scientists found a stone pillar here that tells a tale of an ancient disaster. They presume that the pillar is commemorative. Today, humans still build similar structures to mark an important event or a person. Just one example is the Washington Memorial. It was built in honor of the first American president, George Washington. But the pillar in Turkey doesn't commemorate a happy event. Scientists believe it shows a devastating occurrence, a comet crashing into the Earth. The event must have been destructive. There are also other signs on the monument. These symbols align with the setup of the night sky stars for the year 10,950 BCE. The date astounded the researchers. It matched their earlier research of an ice core sample in Greenland. This showed that a comet fragment hit our planet around the same time. The archaeological site could have easily been an ancient observatory. And whoever worked at it observed a cataclysmic event. The impact must have been so powerful that it changed the Earth's rotational axis. That's the imaginary pole going through our planet from top to bottom. That ancient comet must have packed a punch to knock the blue planet off balance. Have you heard of the city of Tal El Hammam in the valley of the Jordan River? The reason why your answer is probably no is that the city doesn't exist today. It completely disappeared around the year 1650 BCE. It was one of the three major cities in this part of the Middle East. Together, these three cities had a population bigger than Palm Springs today. At the time, Tal El Hammam was a metropolis. It even had high-rises, 5-story buildings constructed using mud bricks. But archaeologists found strange markings on them. The bricks melted as they were exposed to high temperatures. Yes, sound the fire alarm. Some sort of disaster had caused a major fire. Archaeological finds pointed to a suspect for such damage, a rock from space. So, where was the crater? This comet, or an asteroid, never made it to the ground. It was traveling at high speed, so it disintegrated before hitting the ground. Such an event is called an airburst. The largest witnessed meteor airburst happened over Tunguska in the north of Asia in 1908. Scientists estimated that the airburst in Tal El Hammam happened 2.5 miles above the city. This event released a lot of energy. Air temperature quickly rose to 3,600 degrees Fahrenheit. That's hot enough to set clothes and wood on fire in an instant. Mud bricks and tools made from metal start to melt when exposed to such heat. This would explain the evidence scientists unearthed. But there was one more find: salt. The event was so powerful that it distributed salt over the region around the Dead Sea. Any farmer will tell you that salty soil and crops don't go well together. People started moving away from the area because they couldn't grow food. Imagine an island with whitewashed villages surrounded by a sapphire blue sea. Such a place exists in reality. It's the island of Santorini. But the history of this place hides a tale of destruction. The island is of volcanic origin. This means that a violent eruption created it some 3,000 years ago. Now there are two islands. The bigger one is shaped like a horseshoe. When you look at them from above, the two islands look like they form a circle. That's because they were once a single island. It had a large mountain and was round in shape. But then it all changed almost overnight. One of the largest volcanic eruptions in human history tore Santorini apart. The earth trembled, tsunamis formed, and clouds of ash filled the sky. A daunting image. People felt the eruption hundreds of miles away. When it was all over, seawater rushed into the caldera of the former volcano. That's why the water in the lagoon has such a beautiful color. Scientists know so much about Santorini's past because of an unlikely assistant, a tree. The juniper tree, to be exact. People use its aromatic wood for everything from furniture to making pencils. On the Greek island, its rings revealed the tale of the ancient eruption. As a tree grows, it doesn't only go up, it expands sideways as well. Each new layer of bark adds a ring to the trunk. It takes a year for one ring to form. And on Santorini, one ring was unnaturally pale. The scientists did the math and voila, they dated the eruption to 1560 BCE.
It was 11:39 at night when the Titanic's lookout shouted, "Iceberg, right ahead!" Swift action on the bridge to reduce speed and change the ship's course didn't help, and you already know how the story ends. Since then, we've regarded what happened to Titanic as a once-in-a-lifetime event. Is it though? The Titanic sank in 1912. Forget about fancy GPSs or weather satellites. At the time, ships were responsible for warning each other about the location of icebergs, like a "hey man, trust me on this" situation. Then the Titanic disaster happened. To call it a disaster is an understatement, so specialists felt the need to form an organization to avoid this kind of accident happening again. That's why, a year later, they created the International Ice Patrol, or IIP for short. Up to this day, this group has been responsible for giving ships advanced warnings about ice threats. IIP improved their methods over the years, from ship reports and aircraft patrols to satellite images. Recently, they've also been using oceanographic buoys, floating devices providing real-time information about ocean conditions up to 164 feet below the surface to predict the potential drift of icebergs. Luckily, IIP is doing an excellent job in reducing ship iceberg collisions. But don't get too comfortable, because even the most advanced detection equipment can't entirely avoid an unfortunate situation. Between 1980 and 2005, there were 57 incidents involving vessels and icebergs. And the chilling truth is that today's ships are more likely to run into an iceberg than the Titanic was. Studies have shown that 1,038 icebergs crossed the area where the Titanic sank back in 1912. You might think that's a lot, but scientists say it's not really a big deal. I mean, yeah, it's on the higher side, but there have been 14 years with even more iceberg activity since then. Nowadays, the number of icebergs is going up due to the accelerated melting of Greenland's glaciers. And since more ships are heading into polar waters, the chances of ships bumping into icebergs are higher. But the real danger for captains is invisible enemies, called growlers and bergy bits. Growlers are these small icebergs that can be the size of a regular door. And bergy bits are also considered small, measuring around the size of a school bus. These icebergs might seem harmless, but they're actually tricky since they can be completely invisible to radars or satellites. Let's see what happens when a modern cruise ship as big as the Titanic hits one of these small icebergs. Meet the Norwegian Sun, a luxurious cruise ship like Titanic, as it has the capacity to accommodate 2,400 passengers and more than 900 crew members. On July 2022, this cruise ship was on its way to Hubbard Glacier in Alaska when it found itself in the middle of a dense fog. Suddenly, passengers felt an impact and were terrified as the ship experienced a severe jolt. The fog immediately cleared and they realized what had happened. The Norwegian Sun had collided with an iceberg of the growler type. But the outcome was entirely different from Titanic. Thankfully, there were no injuries, and both the passengers and staff reached the Alaskan docks safely. Expert divers checked the condition of the boat, and they discovered that the ship had suffered some damage after the collision, so the rest of the trip was canceled. Now don't stress about packing for your next trip across the Atlantic because accidents like the one with the Norwegian Sun are really rare. I mean, it's common for ships to encounter ice, but what's unusual is for it to be a problem. Most modern cruise ships wouldn't get physically damaged by an iceberg, and there's a reason for that. You see, the steel used in the Titanic also played a significant role in the disaster. The unsinkable ship, after all, was not so impact-resistant. Back then, the Titanic's hull was constructed using around 2,000 steel plates, which are believed to have been produced in an open hearth furnace. As a result, the steel contained a high concentration of phosphorus, oxygen, and sulfur. High levels of these elements make steel brittle at low temperatures, causing it to fail upon impact. While the steel used on the Titanic was of the highest quality available at the time, it wouldn't meet the safety standards of modern ships, and it was approximately 10 times less safe than what today's vessels use. But the most significant difference between the design of the Titanic and a modern ship lies in how the hull is put together. You see, the Titanic was built using over 3 million rivets for its hull and upper deck structure. So, when it struck the iceberg, the rivets started a chain reaction, causing the entire section of the hull to collapse simultaneously, causing an uncontrollable flood of water. In contrast, modern ships use a method called submerged arc welding, which fuses the edges of metal pieces together, creating a strong and continuous bond. This is safer because if any part of the ship gets damaged, the tear doesn't spread, making things worse. The damage remains contained within that section. Okay, so small icebergs are becoming more common, and vessels have been adapted to deal with them. But there's still one more scenario to consider. What if a huge cruise ship hit an iceberg the size of a 5-story building? Imagine we've just created the world's largest cruise ship on the planet. Let's call it the Bright Seaside. Our floating resort is massive, 4 times the size of the Statue of Liberty. It's longer than the Titanic by 318 feet and carries about 3 times more passengers and crew. And just like the Titanic, our fictional ship can cruise at a top speed of around 23 knots. Now, picture this scenario. The Bright Seaside is cruising at full speed in freezing waters. It's the middle of the night, and the captain doesn't realize that all the iceberg detecting equipment on board isn't functioning. It stopped working 3 days ago. It's very foggy out there, and the lookout also fails to spot a 45-foot tall iceberg. If that whole situation played out, and the ship smacked into the iceberg head-on, well, it could potentially lead to a sinking. But you can see how unlikely that is, right? That's why experts are quite confident in saying that ice isn't likely to sink modern cruise ships. It's also worth mentioning that safety measures have improved a lot since Titanic. A modern large vessel can take days to sink, which provides enough time to keep everyone safe. Crews are definitely better prepared to handle evacuation procedures, and passengers should also go through safety training before cruising. I know, it is annoying to do that when all you want to do is drink a lemonade or some other beverage by the pool. But, all these safety tips are what saved the MS Explorer from becoming a modern Titanic. You see, back in 2007, all 154 people on board this Antarctic cruise ship managed to get into lifeboats after the ship hit an iceberg. Now, imagine their panic as they waited for help for 4 hours. The crew did an excellent job in keeping everybody safe, no doubt. But a report that came out 2 years later said that the MS Explorer accident had happened because of the inexperience of the captain, who had pushed the ship too fast into a wall of ice in the freezing waters of Antarctica. That means that no matter how much tech a ship's got or how fancy its materials are, if you've got a careless captain and a crew that doesn't know how to handle an iceberg hit, yep, a disaster similar to Titanic could happen again. But hey, you shouldn't stress over it. Trust the professionals and keep in mind the odds. In the last 30 years, the MS Explorer was the only cruise ship that sank thanks to an iceberg, and everyone survived. So kick back and enjoy your sea vacation. Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems. Those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.
June 29th, 1764, seemed like a regular day in one small picturesque town in Germany, Woodward. Residents were in church. Little did they know that a powerful storm was about to hit the area. It wasn't just an ordinary storm. It was a strong, swirling tornado getting closer and closer. It was an F2 tornado at the beginning, strong enough to uproot trees like oaks and beeches. But as time went by, it grew and became more powerful. It even picked up 2 children on its way and threw them into a lake. Something strange happened too. The water level in the lake rose and then quickly retreated. Leaving the lake behind, the tornado struck a house, tearing off the roof and knocking down the walls. Then the tornado changed direction and headed east-northeast, increasing its intensity to F3 level. That's when something fascinating happened. A possible twin or satellite waterspout merged with the tornado along the shore of Lake Luzin. It was like two tornadoes coming together. It got wider and stronger, so it started snapping and uprooting solitary oak trees, flinging them 115 feet into the air. It left behind a barren landscape, removing crops, grass, and even topsoil. Back then, people couldn't even read or write very well, let alone use devices that could predict a tornado. This one was so strong it destroyed houses, barns, and even uprooted trees. Such a terrifying thing to see. But there was something special about the church people were in. It had strong stone walls, so they were safe inside, even though everything outside was getting destroyed. They didn't even realize how lucky they were until later. With winds estimated to be over 300 mph, it was unstoppable. The tornado traveled a distance of 19 miles and stretched to a maximum width of 0.6 miles. A raging storm threw tree branches so high, people believed they ended up in the atmosphere. Another strange thing about this tornado was that it occurred during a dry storm. There was very little rain reported, but the storm still managed to make such a mess. It even produced large hailstones, some as big as 5.9 inches in diameter. Just imagine chunks of ice that large falling from the sky. These hailstones caused significant damage to crops and properties, and everything else that was outside at that time. After the storm passed, one scientist, Gottlob Burchard Gensmer, studied the damage and talked to people who had witnessed the tornado, only to realize this was one of the strongest tornadoes ever recorded in history. It reached F5, the highest rating on what's called the Fujita scale, which measures tornado strength. It took an hour for the madness to stop. Back in 1925, people in northeast Missouri didn't have an organized tornado warning system either. It took them by surprise when one day, in the early afternoon, they saw a tornado forming in that area. At first, it was a small one that briefly lifted off the ground. But as time went by, it started growing into a massive monster. Meanwhile, in West Frankfort, Illinois, some miners were working deep underground, about 500 feet below the surface. Suddenly, the power went out, and they knew something was wrong. They quickly started climbing up the shaft to get to the surface. When they finally made it, they were in for a terrible shock because of the devastating consequences of this giant tornado. The tornado didn't even stop there. It kept on making a mess as it traveled a long distance. It plowed through the land for a whopping 219 miles, all the way from near Redford, Missouri to the east of Princeton, Indiana. It moved at a crazy speed of 73 miles an hour. In one town, Murfreesboro, Illinois, the tornado wiped out a staggering 100 blocks of the town, plus another 70 blocks ended up destroyed by fire. In another town, Griffin, Indiana, not a single building was left standing. The tornado got weaker only at 4:30 in the afternoon. This tornado, known as the Tri-State Tornado, really made history as the worst and longest-lasting tornado ever recorded in the United States. In April 1965, people in the region of the Great Lakes started complaining about this weird heat. The forecast showed no storms for that area. It was because of thunderstorms sweeping across the upper Midwest of the United States. These storms were insane and so powerful they created 51 tornadoes in just 12 hours. The states of Indiana, Ohio, and Michigan ended up being hit particularly hard. Something unfortunate happened during this time. All this caught the forecast team, the National Severe Storms Forecast Center in Kansas City, Missouri, off guard. They quickly tried to send out warnings to let people know what was happening, but many people didn't hear the announcements because there were no outdoor tornado sirens at that time. Additionally, a lot of TV and radio stations didn't regularly broadcast weather alerts. Power was gone, and telephone lines didn't work, which meant many towns were completely cut off from communications. People couldn't receive the warnings because they didn't have access to electricity or working phones. One spring day in 1974 was especially hard because of severe thunderstorms that unleashed a series of powerful tornadoes across 13 states in the United States. These tornadoes lasted for 16 hours, and they ranged from weaker F0 to the most powerful and destructive F5 ones. At one terrifying moment, there were 15 tornadoes touching the ground at the same time. One lasted for more than 2 hours, and 2 others were swirling around each other like dancers. This was another big lesson, after which some changes in tornado warnings were made. In those days, weather forecasters could only warn people about a tornado if they had seen one with their own eyes, which was mostly too late. April 26, 1989, at around 6:30 in the afternoon, the sky above one district, Maniganj in Bangladesh, turned dark and ominous. The tornado began its journey from one point, Daulatpur, and moved swiftly eastward, Saturia, Maniganj Sadar. People living in that region had already been facing a severe drought, and little did they know there were even worse scenarios coming. The storm was fierce, stretching about 10 miles long and 1 mile wide. It covered a relatively small area, but it still caused enormous damage. It tore through the land and blew away buildings, thousands of trees, strong and rooted for years, and everything else in its path. The countryside of Marsala in western Sicily is really beautiful. But it wasn't so stunning on December 8th, 1851. Two fierce tornadoes suddenly swept across the land, leaving nothing but chaos. As they moved, they brought along heavy rain and hailstorms, causing even more damage to the already vulnerable farmlands. One town, Castellammare, had an amazing harbor with plenty of ships, and it suffered great damage. The news of this devastating event reached far and wide, even making its way to the Illustrated London News. The outbreak in Oklahoma from 24 years ago, May 3rd, 1999, was tough too. Just one stormy day caused enormous damage from Texas all the way up to South Dakota. At least 45 tornadoes touched down, and Oklahoma was hit the hardest with an F5 tornado. The story seemed familiar. What first seemed like a small twister quickly grew into a massive force that, at one point, measured 1 mile in width. This one ripped asphalt from roads, peeling it away in layers like fragile paper. It tore the vegetation away and even wrapped roofing materials around power lines. NASA scientists studied the area using satellites. They realized it would take between 10 to 20 years for the vegetation to fully regrow in the region where the tornado left nothing but muddy, barren land. Oklahoma is in a pretty unfortunate spot when it comes to tornadoes. Take 1947 as an example. The Woodward tornado got named after the city it had struck. This monstrous tornado was massive. It reached 1.8 miles in width, and it raced forward at an incredible speed of around 50 mph. Before reaching Woodward, the tornado had already caused a lot of mess in other towns along its path. But it was in Woodward where it unleashed its worst fury. Without any warning, it struck the city at 8:42 in the evening, catching the residents by surprise. Communication with the outside world was cut off, leaving families uncertain about the fate of their loved ones. As if one tornado isn't enough, some areas get struck by a series of them. In 1908, an outbreak of tornadoes swept across the eastern part of the United States, from Texas to Georgia and then northward from Oklahoma to Tennessee. At least 34 tornadoes touched down. Nature showed no mercy. Buildings were torn apart, and once thriving streets were reduced to rubble. The Fujita scale measures tornado strength based on two things: the speed of the winds and the amount of destruction caused. F5 tornadoes are the strongest, most destructive ones. I mean, some people talk about F6 tornado with winds that could blow at over 300 miles per hour. If this one was passing by, you'd definitely know how Dorothy felt. Luckily, F6 exists only in stories, and Oz is the last place you are likely to end up at.
The air is bone dry and the wind is out of control. You feel like you're standing in front of a fireplace, but you're not. You're standing in your backyard about to grill up a feast when you suddenly see the trees shaking uncontrollably. Leaves are falling like confetti. The wind just blew your last piece of laundry into the great unknown. You look around and everyone else is just as confused and scared as you are. In the distance, you see a red horizon of fire in the forest and a large vortex touching the sky. You drop everything and make a break for it. You'll be lucky to outrun a tornado. They usually move at around 30 miles per hour, but can reach up to 70. Imagine running away from a giant twister, hurtling towards you at Usain Bolt speed. The roads are crowded with people trying to find shelter or just get out of town. You get in your car and try to start it, but the wind knocks a sign over. It smashes your windshield. Anyway, a big tornado is powerful enough to swing your entire car around. You gotta go on foot. Best bet? Head for your buddy's house. They have a deep basement stocked with supplies. Whenever a tornado flies on by, try to take cover somewhere underground. If you don't have a basement, avoid any windows and try to stay underneath something sturdy to protect yourself. You're running to your friend's place. Everything around you is getting swept up by the insane winds. But when you turn around, you see the tornado turning reddish. You can barely see it because of the debris, but the spinning vortex, it's on fire. It's a fire tornado. These spinning flame winds can reach 140 miles per hour and can be between 15 to 150 feet tall and as much as 500 feet wide. These monsters occur when tons of smoke get whirled around, so the thunderstorm starts to act like a tornado. By the way, many fire tornadoes can even occur in a bonfire and are called fire whirls. Next time you're camping or setting up your living room fireplace, check it out. You might just spot one spinning around in there. Anyway, it's getting closer and closer, throwing ash all over. It's already pretty hard for you to see where you're going. You use your hands to wave off some of the smoke and ash flying around your face, but it's useless. You keep sprinting as fast as you can until you spot a huge truck. Just park right there in the middle of the road. You crawl underneath. It's one of those trucks that has like 20 wheels. They look so big and heavy up close. Then you hear a creaking sound and a humming sound. The wheels, they look magical. Gracefully, they start lifting off the ground, as if the truck's part of some Vegas magic act. As the tornado gets closer, the wheels rise higher. Better to be far away from here when the truck smashes back down to earth. You crawl out and keep running. You find a convenience store to take cover in, making sure not to stand too close to the glass. You head as far into the store as you can, ready to wait this thing out. But all around you, the land is burning. This fiery twister is a monster, and it's charging towards you. You look out in the distance and see another fire tornado wrecking another part of the city. In order for a tornado to form, it needs open space. That's why many of the tornadoes you see on the news happen in the same part of the U.S., where there aren't many mountains and it's nice and flat. But of course, they can happen anywhere. It's not normal to see tornadoes in the bustling downtowns of America's biggest cities. They need a lot of open space for the rotating vortex to happen. But today is not a normal day. A tornado forms in a supercell thunderstorm. That's when you have two different air temperatures going at it. The vortex you see in tornadoes forms when warm air and moisture come in from above. Below, it's a mess. The end result, the huge spiral funnel cloud we see in every tornado movie. Meteorologists can predict tornadoes somewhat by monitoring the amount of moisture in the air. Every second counts, so keep the TV on next time there's a storm brewing near you. But this doesn't really apply for a fire tornado. The winds are getting stronger and you're feeling the heat even inside the store. Outside, spiraling flamethrowers are torching everything in their path. It may be too late to find an underground shelter. You improvise a way to help protect yourself by hiding underneath the cash register. And now, you can't see anything. There's ash everywhere and the windows are all smashed. Thanks, tornado. Ash is one of the most dangerous parts of a fire tornado, unless you're not really into breathing or seeing. Your best bet would be to stay as low as you can to the ground. Since smoke rises, there might still be just enough oxygen down there. Crawling your way along will prevent you from getting struck by any flying objects or debris. The fires are now spreading, and there's a lot more smoke. The trees outside have caught fire, and there are glowing embers as far as the eye can see. These embers can travel more than a mile and can start fires on their own. Now that it's really going crazy, stuff in the store starts flying about, like the smoke wasn't bad enough. You feel like you're inside a snack-filled erupting volcano. It's only a matter of time before the table you're hiding under will get pulled up into the air. The sound inside the store is intense, like sitting next to a jet engine. You can't tell if you're sweating from the heat or from adrenaline. But suddenly, you see someone at the other end of the store waving at you, trying to tell you something. They have an underground storage room. You're saved. But getting there is going to be a real problem. You see, the table screw's getting loose, getting ready to fly into the air. You find a bottle of water next to you and rip a piece of cloth from your shirt. By using a wet cloth, you're able to filter out some of the nasty stuff in the air to help you keep breathing. So you crawl your way out from underneath the table and make your way to the underground storage room. But the ground is covered with broken glass, and there are cans and stuff everywhere. Even the cans are starting to heat up. You crawl like a sloth, trying to avoid anything pointy. The fire tornado is still out there, and it's getting even closer. You finally make it, and the clerk pulls you down the stairs. It's dark, but there's a single battery-powered lamp to help you see. When it comes to fire tornadoes, it's best to just wait it out. Most of these firestorms don't last that long. So you relax, or try to, and wash your face in a nearby sink. You wipe off all the black ash from your face and breathe normally again. But as you get a bit more relaxed, you feel the ground shaking. Everything around you starts to fall. You and the clerk duck behind a pile of canned goods. Then the tornado takes it up a notch. The store above you gets lifted up off the ground. The only things left, steel and concrete foundations and a couple of random columns. The steel door that's separating you from the outside is barely holding it together. You can see the screws getting loose. You can actually see fire enter the storage room. Everything in the room gets toppled over in an instant. The wind is even louder than before. But then, it's over. Those few minutes felt like hours. You and the clerk climb out and see, well, not much to be honest. The convenience store looks like it got ripped off like a Band-Aid.